to a new series called Small Talk. Today we are going to discuss about an intriguing topic of mechanical or battery physics topic, which is Coriolis Effect. So without further ado, let's dive into it. So before talking about the Coriolis Effect, there are two important terms which we need to remember while we discuss about Coriolis Effect. That is inertial frame of reference and non-inertial frame of reference. Within the realm of Newtonian physics, an inertial frame is one in which Newton's first law of motion is valid. Just imagine you are on Earth and assume you could remove both friction and air resistance. Now hit a ball gently, so it moves slowly along a perfect smooth road with uniform velocity. If we were on a strict inertial frame of reference, ball would move in a straight line along the road. But it's not the case. Due to Earth rotation, the ball's path is ever so slightly curved. And the same effect is the culprit when we are shooting a target. It does not follow a straight path. That's why a very experienced shooter only make a bullseye. As you can see here, if you shoot a bullet and you are north of the equator, the bullet is deflected to the right. If you are in the south, the bullet is deflected to the left. And similarly, if bullet is fired to the west, fly lower than those fired to the north or the south. And bullet fired to the east, fly higher. This same problem was faced by the scientists during World War II because during that time the army of both the side, the Allies as well as the Axis, they want to hit a particular target, but the cells they fired always hit somewhere else, and that's the problem. So for discussing it after the World War II, when the, the World War II end, the scientists discussed about this, and they found out that there is some effect which is called as a Coriolis effect, which is causing this. We can visualize the Coriolis effect here, but in a better sense. As you can see here, in a merry-go-round, when they are pushing a ball or throwing a ball toward one another, it does not follow a straight path. It is following some curvilinear path. Same is happening in second GIF, where a man who is spinning around and throwing a basketball. It does not follow a straight path. As you can see here, it is following a curvilinear path. So let's take the help of maths to know what is actually a Coriolis. Here you can see that this x, z, and y are the inertial frame of reference because they are fixed, which are denoted by the blue axis. Similarly, x dot, y dot, and j dot are non-inertial frame of reference because they are moving, and we want to know the velocity and acceleration of point P, which is a inertial frame of reference. But we are seeing it from here, inertial frame, which is x, y, and z. So the position vector r of P will be described as r dot plus r dash. And when we take a time derivative of r, the r naught will simply will be uh, dr naught by dt. But what will happen when we take a derivative of time derivative of this r dash? We will get this two term. This is because the position is also changing with respect to time. So we got three term over here: v naught plus omega into r dash plus v r dash, or we can call v rel, which is v relative with respect to moving frame. Similarly, when we take further time derivative of velocity, we will get this 5 acceleration term over here, where a naught is acceleration of this origin point, a relative is again this r dash double dot, Omega dot is nothing but alpha, which you can call angular acceleration into r, r dash, which is again this is over a term of angular acceleration, caused by angular acceleration, and this is caused by centripetal acceleration, omega square r, or cross product omega cross omega into r dash. And this term over here is Coriolis acceleration, 2 omega into v rel. And due to this only, the Coriolis come into the picture, and this is this is the culprit, or this is the reason why there is shift, why when in World War II, when we don't know about the Coriolis acceleration and we design the aeroplane, and when we turn left or right, it does a catastrophic effect, because sometimes planes go up, sometimes planes go down when we are turning right, when we are turning left, and that's resulted in the catastrophic failure. So let's end this topic. The small talk is